So what we've been doing is we used an open statement to read the file, and then we use this general syntax for something in the file handle. Do something with it, like strip it, whatever, remove the spaces from it. Then do something with that data. And so the code, what they've written here, they have a long series of emails here in this file. And over here, what they're trying to do is to find every mention of this address at uct.ac.za. And so that's what it's going to do. It's going to open this file, read in the line, rstrip, so right strip it, I mean you take off the stuff at the end of the string, then check it to see if it's got that value in it, and there's always more than one way to do it, but that works. If line.find, if it does find it, it'll be the index position at which it's found. If not, it returns a -1. The continue we haven't talked a lot about, but I know that we have talked about it. It just forces a reiteration of the loop right then and there. Just like a break bails you out of the loop, continue tells it to go back up to the top and keep going. This little syntax here of putting the word on the same line as the if statement before it is legit. You don't have to do it though, or I very rarely do it. So running it, we would see it open the file and just go through the entire sequence from author, from warning, from author, from, So we could change this text a little bit just to get all of the froms in it. So I'm going to change this line.find to from : and run it. And we should see there, in that mail file, these are all the addresses from whom we have received the email. So letting the user choose the file name is a good idea. I was always putting in our code, file name and then something equals open file name. Well, you can prompt the user for that file name. That's what they do here, except instead of calling a file name, they call it fname. Fname is equal to input file name. And if we typed in that file name right there, then what's the program going to do? It will be able to open the file, and if the line begins with the word subject, it'll add it to the count. It'll keep doing that as it processes the entire file. This guy doesn't bother closing his files when he's done with them. If we wanted to do that, we could. How do you close? You use the file handle .close, like that. So if we run this, it's just going to count the number of subject lines that are in this file. So let's run it. Enter the file name. Well, I better type it exactly as I got. Well, what if I type something wrong? It blows up. No such file or directory. Alrighty. We saw that we could use try in order to try to catch that kind of problem. No pun intended. Try and accept. There are other ways. You can just check to see if the file exists before you try to open it, I believe, using, let's go figure out how to do that. How do I check to see whether a file exists? There's something called path from a library called pathlib. You can create a file using the path statement, and then if it is a file, that means the file exists. We might want to play with some of these. The various functions in the OS library. Miscellaneous Python operating system interfaces. Please show us for Python 3. Okay. So what do we have in here? A lot of these are not going to make a lot of sense to us at this point. CTerm ID returns a file name corresponding to the controlling terminal of the process, available in Unix. Alrighty. Environ represents the string environment on Unix. Alrighty, so what this does is allow us to get environment variables out from your operating system and to do things with them. And we talked about environment variables way back when. But if you do set, if you open up a command prompt, Windows R, or however you do it, type in CMD, type in set, you see a list of all of the environment variables that are currently set for your computer. And so, for example, our program could try to find out what the username is, the environment variable username. I think that'd be kind of neat to see if we can get that going. I'm kind of flying off the map here, but I do want to do this. So let us go and do a new file. October 26. So let's just import OS and then see if we can do. This is actually, looks like it's using a dictionary, which is a data type that we haven't discussed yet, but that's okay. So top line, import OS. And then let's do this. A is equal to OS dot environ parentheses. And what was that variable name I was curious about? That was, I wanted the username. Here he is, username. Okay. I'm not sure this is going to work. Username in all caps. And then let's just print out A. Square braces, actually. Believe it or not. That'll be the new bit of information. Actually, that's probably the most important thing to draw from this, is what that is actually doing. All right, and I found my username. Cool deal. So you can make a program that would do something based on the behavior of some of these environment variables. And these environment variables are set by the machine and by the login scripts and things like that. I don't see anything in here else that's just incredibly cool, but we want to find out where their user directory is, where their program files directory is, their home path, the local app data path. I'm curious about that one. I'm just going to open that up in a folder and see what it looks like. Okay. Anyways, that gives you a way of interacting with one particular aspect of the operating system, which is the environment variables that have been set. Obviously, the OS library has a great many more. chdir to change your path. Get CWD to get your current working directory. Let's do that. Let's find out what our current working directory is. So up here, I'm just going to print D is equal to OS dot get CWD, current working directory. Print D. That's my current working directory. Sure enough, I saved my program, my script, into that directory, and so when I ran the script, that was its current working directory. If I wanted to change it, if I wanted my program to change to run in a different directory, I could do that. CIT1203. Return to file system presentation of the path. Nah. We've used get environment. This actually behaves more like. This is the one where you would use the parentheses rather than the square brackets. So that's actually really fairly important for us to start talking about. This is using something known as dictionaries. I'm going to veer off from talking about files to hit the chapter on dictionaries, which is chapter 9. What is a dictionary? It's like a list, but it's more general. Yeah, that's useful. In a list, the index positions have to be integers. You know, you say element 0 is Fred, and element 1 is orange, and element 2 is black, you know, whatever. But in a dictionary, the indices can be of almost any type. Looking for the shortest example that would get us into it. There, we're not seeing our little code bracket here. Alright, but we can do it like this. Dictionaries are not defined with the square braces. They are declared with curly braces, and what we do are we are mapping pairs of values together. Here's the English version of the word that means one, and here's the Spanish. And then again, here's the English, and then there's the Spanish. And there's the English, and then there's the Spanish. So let's do something like that, but we don't have to use that kind of thing. Let's do this. Foods. I'm going to list some favorite foods. Fred likes pizza, comma, while Wilma likes ice cream, comma, while Barney likes steak. We have created a set of mappings. First I'm going to run this to make sure it worked. You don't have to space it out like that, but you know my general problem. Okay, fine. That was supposed to be foods is equal to, for one thing. I forgot my equal sign. Go ahead and don't forget it on yours. Alright, so it hasn't done anything yet. It didn't print anything out, but that's okay. We have declared a so-called dictionary, a mapping system where we can map pairs of values together. So if we want to, let's print out foods for Fred. And sure enough, Fred likes pizza. Let's print foods for Barney, just to make sure that we're not confused that it's doing them, you know, just pizza, ice cream, Barney, you know, steak in that order. We're going to print the first one, then the third one. And we should say pizza followed by steak. So not that I've given thought to it, but when might you want to have pairings, you know? When you want to be able to map one set of values to another. Well, that example that they gave us there, of Spanish words and English words is the absolute perfect example. That's why they're called dictionaries, right? You have an English word and then you have a Spanish word. And so you have a mapping of them. And then we did a silly example of food to people. If you try to access something that doesn't exist, let's try to print out one for somebody that doesn't exist. I'm going to go back here to my code and print out the food for Joe. Well, Joe is not in our map. Joe is not in our dictionary. And so it says key error. It's one of those red errors. We could put it in a try-catch. There are more elegant ways of handling it than doing try-catch. You could check to see if that key is in the dictionary rather than just blow up. What if we set up a dictionary like this? We're going to keep track of some field goals that these people are kicking, or that these people are doing. And we're going to say that Ringo has kicked 0 field goals. John has kicked 0 field goals. That's supposed to be a colon between them. Sorry, each pair needs to be mapped with a colon between them. And Paul has kicked. And we're leaving out. We're leaving out the 4th. Yeah, poor George. We may as well do George. Alrighty. Okay, keep me honest. Alrighty. And then George, who has that many goals. Now let's enter a loop where we ask who kicked the goal, and then we increase that person's goal each time that they do that. So we're going to need a while loop. I'm just going to make it a while true for now. I like while true because I don't have to think right at the very beginning of how I'm going to get out of it, because I know I'm going to use a break statement. So let's print who kicked the goal. And a name is equal to input. Now we should validate it. We should validate that that person is actually in the dictionary. But we're just going to assume that it is. So let's get their current number of goals. Goals is equal to, I don't want to reuse the word goals. I'm just going to use X. X is equal to the goals that that person has kicked. We're going to add 1 to it. And then goals at that person has kicked is now equal to that value. Does that make sense? We're getting their value. We're checking it out of the dictionary. We're adding 1 to it. That was supposed to be X plus equals 1. Sorry about that, guys. Yeah, GLOLs. That's a new kind of game. All right, there we go. And let's go ahead and put a break condition in there. Or quit to stop. If name is equal to quit, we could be really fancy like they do and put it all on the same line. Then let's print out the list each and every time. So after we've put that value back in as the person's new goal score, then let's just print out the entire goals object, like printing a list, except we're printing the dictionary now. Oh yeah, that's right. I forgot to remove this error. If you get an error about Joe, comment that line out and try running it again. Who kicked the goal? Well, Ringo did. Ringo now has 1 goal. The rest of them have 0. John did the next one. Now George, who was really upset at us for almost leaving him out, is going to get 3 in a row. George, 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 and then I'm going to type in something that doesn't exist, and it's going to crash it. Bob. Bob's always getting in the way. Alright, so I hope you see what was going on there. When we typed in George, I'll bring the code back in just a second, it looked up the value for George, which was currently 0. It added 1 to that value, and then it reassigned that value. So it is a 1-to-1 correlation. You cannot have multiple keys in the dictionary that are the same thing. It'd be like, well, can't even think of a good example. These keys need to be unique. If you try to set Ringo and then you try to set Ringo again with something else, then when you do that, you're only going to get to see the second value. Maybe we could demonstrate that with the shell. All right, anybody need this up? All right, so let's go to the Python shell. I'm going to do D is equal to DICT parentheses in parentheses, which makes D a dictionary, an empty dictionary, so we can start storing anything in there that we want. And now we're going to say that D Ringo is equal to 1 because he scored 1 point. Then we turn around and try to go D Ringo. He likes playing the drums. So when we print D, it's only going to have one of those values. Because it's setting up a mapping. It's not storing a list. If you want to create a list out of it, you're going to have to do something a little bit different. You could make it a mapping between words and lists if you wanted to. So the first value here, this is known as the key, and this is known as the value. You can make the value be a list, but you can't create duplicate keys within your mappings, within your dictionary. So you could print the length of the dictionary out, and what it does is it prints out how many pairs there are. So when we ran our scoring program here, and Ringo scored the goal, how many pairs are there? There are 4 pairs, right? 4 names, 4 numbers, so there are 4 pairs. So if we printed out LEN parentheses goals, it would print 4. That's how many items are in the dictionary, how many pairs. How many linkings? You can check to see if something is in there by using the IN keyword. Is this item in the list? We could correct that error that we got when we typed, Bob, and Bob wasn't actually in our goals. So let's do that. Right here, underneath if name is equal to quit break, and above X is equal to goals name, let's make sure that that person is in the dictionary to begin with. If name is in goals, then tab those next 3 lines over. And if they're not, well heck, let's add them to our list, add them to our dictionary. Else, X at that name is the first score for that person. Cool, we'll give them a 1. Now what I'm going to do is I'm going to comment out this line that says goals equals here, and I'm just going to replace it with goals equals dict, like that. You see what I did? We're starting with an empty dictionary now. So who kicked the goal? Bob did. X is not defined. Okay, that was a mistake. Why did I type X? What should be there?
Goals.
Should be the name of the dictionary. Right, goals. So make sure your else clause is now fixed like that. So who kicked the goal? The goal. Bob, Joe, Ringo, Sam, Bob, Jack, Jill. You see what's happening.
It's case sensitive too.
It is case sensitive. You're right. So, Sam went on a winning streak and got 4 goals here, but if I type in Sam with an uppercase, then all of a sudden he has a competitor named uppercase Sam. So you can use this to keep track. This is a frequency table. Like you could open up a file and you could count the number of words in the file, creating a dictionary that says that the word "the" occurs 20 times in this file, and the word "a" occurs 10 times in this file, and the word "Sam" occurs, that many times. And so, just for funsies, let's go and create a file that's like that, and then we're going to use file.io to build our dictionary. So let's do a file new, and do a save as. Call it story.txt. We're going to write a story. You don't have to write the same story I do. And I forgot to save it as a PY file. No, maybe I didn't. Make sure you save it as a TXT file. Okay. So, then write a story. There once was a big bad wolf. The big bad wolf ate grandma. Little Red Riding Hood ate the wolf. The end. There. We got a good story. So we're going to write some code that's going to read that in and then separate it word by word. Each line is going to be broken up into a list of words. What was the function that we used that split I just gave it away. That split a string up into a list. It was split. And when you split, you can split based on whatever you need to do it on, including spaces and periods. We might go through and replace all of the punctuation, commas and periods and question marks and exclamation part, just with periods. So I'm going to just save that, tuck it away, minimize it, and I'm going to make a new script so that I don't have to keep answering these questions about goals and stuff like that. So file new, October 26B, the story reader. Save as October 26B. So file name, or F name as the textbook was calling it, is equal to story.txt. Now how do we open that? What's the line of code that would create a variable that's associated with that file? Yeah, we're just going to use file is equal to open. And then we're going to pass that file name in. And we're going to dearly hope it exists because we didn't put a try except around it. We could though. Why don't we be good programmers? Let's do this. OK is equal to false. And then try this. And if that works, let's set OK equal to true. But if it doesn't work, let's print out an error message. So except : print could not open, end quote, comma, file name. Then, if okay, colon, if our file was okay, we can do some stuff. For every line of data in the file, for every line in file, firstly, let's just print it out. Let's get the bare bones up and running before we do anything else. And then lastly, let's print done down here at the bottom. It would be. It would be. Not print as, print line. Thank you. All right, so it printed out our story, and it has the same problems as we've always had. We need to strip it. We need to split it up. So before we print the line out, we're going to do line is equal to line.strip. Now let's start replacing the values in our line. Line is equal to line.replace every period with a space. And then line is equal to line.replace every comma with a space. I think in this case that's enough, but we could go ahead and do the other ones. I'm going to move that print line to underneath those replaces. And I'm just going to test it. There we go. So we see what it's doing. It's taking our punctuation and replacing it with spaces. Why? So that when we call dot split, we won't have all those extraneous punctuation adding to our words. We may as well do exclamation marks and question marks while we're at it, in my opinion. So replace all question marks and exclamation marks, and that's about enough. I don't think we need to go overboard. Alrighty, so we have this nice clean data. Clean meaning that the punctuation has largely been removed. So we need to separate that into a list. List, I'm just going to call it capital L, is equal to line.split. And then let's print that list out and then run it again and see if that we like where this is going. Yeah, see, it's making lists out of it. There once was a big bad wolf. The big bad wolf ate Grandma. Little Red Riding Hood ate the wolf. The end. All right. Now, as you noticed, it is case sensitive. So it's not going to like the fact that sometimes we have the word the in uppercase and the in lowercase. So we'll probably want to fix that at some point. But let's go through that list, adding every word in the list to a dictionary. Using that same kind of code that we did with that Ringo goal list. We're going to have an empty dictionary though. So I'm going to make something called up here called word count. And I'm going to set it equal to an empty dictionary, like that. Now that we have our list of words, we could comment out these prints. We don't really need them anymore. Let's process that list. For every word in the list, if that word is in the dictionary, X is equal to word, no, not dict. For every word in our word count list, let me just revise that. For if word in word count, then X is equal to word count for that specific word, square brace word, X plus equals 1, and then word count, the new word count for that word is now X. else it wasn't in there. And so we need to build a new entry in our dictionary for it. Word count, square brace, word in square is equal to 1. We found our first occurrence of the word. Now, just to watch the list get built, let's go ahead and print our word count each time. We're going to wind up commenting it out. Just to keep track of where I am, I'm going to put an end for word in list. It's just as a comment. And then after that, I'm going to put a end for line in file. Just so that I can match these things up, right? And this last one would be the end if okay. So somewhere in here we need to figure out where to close the file. Where would be a good place to put our file.close command? I'll give you a hint, it's not here. What would be wrong with doing it here? Well, what if it never successfully opened the file? If it didn't open the file, if we got an error message, it would skip all of this stuff, which is good because we don't have a file, but then it would try to close it, and that file doesn't exist to begin with. Yeah, let's put it here. Like that. Alright, I hope this actually works. So the word wolf occurred 3 times in my story. Bad occurred a couple of times. It did treat the uppercase and the lowercase as 2 separate words, and we don't really want it to do that. So why don't we change our word to uppercase before we start doing anything with it, or lowercase. But word equals word dot upper. Does that do it? Yeah. So that does a frequency count of all the words in that file. We could go and copy something big off the internet and paste it in there, you know, some big block of text. What's the name of it? Edgar Allan Poe, The Raven. I'm Googling up The Raven. Am I going to be able to find it? Text of it easily. Alrighty. I'm just going to grab the whole shebang, paste it in there. It's got lots of punctuation that we didn't handle. Dashes and quotes and stuff like that. It's alright. I'm going to go into my story and I'm going to replace that story with this. Save it, run it. I'm not going to print out all the intermediate terms, so I'm going to comment that out and only print out my word count when I'm done. Ooh, and it blew up. Alright, it just found some data it didn't know how to handle. Oh well. Who knows what I pasted in there when I tried to paste that in there. Probably these funny backslashes or something. Won't mess with it. Won't mess with it trying to get it to work. So that's the idea behind dictionaries. You can use them for counters, but you can associate anything. to anything, pretty much. Not just words and numbers or words and words like we were doing. Let's give one more example of that, and then we'll probably call it a day. Let's go to the top of our program. Import turtles, because they are our favorite things. We have a gang of turtles, so gang is equal to, I don't really want to do this example after all. Never mind, I'm not going to bother doing that. But you can correspond, anything that you can conceptualize in your head as being pairs of people. One thing that people do with these things is, here we've been treating them, I'll just give an example. Okay, so make at the top of your code a new dictionary called male, and then do this: male, square brace, subject, in square brace, equals to whom it may concern. Mail sender equals joe@bob.com. Mail recip, I should just put to and from, right? Let's make that first word to and that next word from. Is equal to sam@wally.com. And then mail body, the text of our message, is equal to, are we done yet? You see what we've done here? We've created a piece of data that is a series of mappings and elements. This piece of data maps information about a mail message. Each mail that we get would have a to person and a from, a to value, a from value, a body value, and a subject value. We're kind of treating it as an itty-bitty little database at this point. I don't know if that makes sense. But the difference between the way we're using it here and the way we used it for word count and for our goals, our field goal kicker list, is that those were list of elements. I don't know how to explain this precisely. It was for a group of things. You had a group of field goal kickers, right? Or you had a group of words, and we're establishing counts. Here, instead, we presumably have a single object, a single piece of mail, and we are giving attributes to that single object. It would be as if you would have a turtle and his color, don't type this, his color was red, and the turtle's, direction, what angle he was going at, is equal to 90, and so on. You can use dictionaries to create one thing, which is a series of attributes and their descriptions, or you can use dictionaries to contain data about a bunch of conceptually related things, like the words and their word counts, if that makes sense. I hope that does. To test to see whether something is a value in the dictionary, you can use the method values. Okay, fine. We'll give that. Go to one of our programs. Why not the word counter one? After print word count, do print word count dot values. We're just going to see numbers at that point. Oh yeah, my turtle stuff. Sorry. If you were typing those turtle square brace things, go and get rid of them. All right, you see what happened here? Those are just our values, not our keys, right? Here we see a correspondence between keys and values. Key, value, key, value, key, value, key, value, key, value. Here we just see a list of the values. Why do you care about that? Because you might want to look up to see if a specific value was in it. You know, if you have an English or Spanish dictionary, you do care about whether the English word is in it, but you also care about whether the Spanish word is in it. You could look up the English word in the keys, but you'd have to look up the Spanish word in the values, like that. So a dictionary is a set of counters. That is what we did. And we're going to go in this direction. This will probably be our next assignment. Suppose you're given a string and you want to count how many times each letter appears in the string. There are several ways to do it. You could create 26 different variables, right? Here's my number of A's. Here's my number of B's. Here's my number of C's. Or you could create a list and assume that the first position in the list is the number of A's, and the second position is the number of B's, and the third one is the number of C's. Or you could use a dictionary where the letters are the keys and the values are the number of times that each character, each letter appears. That's very similar to our word count. Did they give us a code for that? I hope not too much of it, because that's actually what our homework is going to be. But we'll work on that on Tuesday. I hadn't seen that. Alrighty, so go ahead and stop and upload your two PY files and your story.txt file. Dropbox.